Okay, now that we have learned about rational numbers, we're going to move on to some more algebra and look at expressions and how to represent and translate expressions. In this unit, you are allowed to use a calculator if you need to. Remember, pause the video whenever you need. So an algebraic expression is a mathematical expression consisting of numbers, operations, and one or more variables. That is an algebraic expression. Expressions do not include an equal sign. That would be considered an equation. So now let's take a look at the parts of an expression, an algebraic expression. So first of all, let's talk about terms. Terms are values added or subtracted. In our example, 8x minus 12, we have two terms. 8x is one term, 12 is the second term. The terms are separated by addition or subtraction. Now let's take a look at variables. Variables are symbols, usually letters of the alphabet, that represent unknown values. In this example, we can see that x is a variable. So it's 8 times some number minus 12. Now let's move on to coefficients. A coefficient are the numbers multiplied by the variables. In our example, 8 is our coefficient. It coexists with the x, 8 times x, and typically the coefficient is always in front of the variable. The next part of an algebraic expression is called the constant. This is a number that remains constant. It never changes. So it's a number, it's by itself, no variable with it, and it never changes. So minus 12 is always minus 12. No matter what x may be, whatever value of x, we're still going to constantly subtract 12. Before we get to factors, let's look at variables and coefficients and this little caution at the bottom. The sign that is in front of a variable, a coefficient, a constant, belongs to that term. So in this example, 8x is positive, where this 12, this constant, is really considered to be negative 12. So if we had negative 4x plus 3y minus z, this z is a negative 1z. This y has a coefficient of positive 3, and this x term has a coefficient of negative 4. So this is how I like to do it, okay? And then this negative belongs with this z. This is understood negative 1z. So factors are the values that are multiplied. In our example, we take a look at, let's document this. This is our constant. But remember, the negative goes with it. So back to factors. So here, the only multiplication we have going on is in the first term. So this term 8x has two factors. So 8 and x are the factors of this term. 8 and x are the factors because they are being multiplied. Okay, so let's talk about translating from English to mathematics or vice versa. It just requires the understanding the language of functional operations. So when we read a phrase or a sentence, we will be able to write it with math terms. The following chart lists some words, some very common words, and their operational meaning. So I'm not going to read through all of these, but here are a list of common words that mean to add, subtract, multiply, division, and then equals. So if we use equals, we're not really looking at an expression, but an equation. Now we will get to the words added to, more than, less than, subtracted from. You can see that these are all starred, and those have a special meaning, and I like to call those flip-flop phrases. So if you want to put a star, and this is just my own little word, flip-flop phrase, and you will see that we will be, if these terms are used, we'll be flip-flopping the order of our phrase into our mathematical sentence. So typically each word is translated into a mathematical symbol in the order that is written. And we can use any variable to represent our unknown. So usually I use X, you can use N, you can use any variable that you choose. You can use the first letter of your name or whatever you like. So again, 8 plus a number is simply 8 plus and then some variable. Twice a number means multiplying by 2, so 2 times some number. The quotient means divide, and then you write it. We're always going to write in algebra, we're going to write it as like a fraction, okay? We're not going to use the division symbol. The quotient of a number and 2. So the order that it appears is how you write it. So the variable is on top here, and then the 2 is on the bottom. Okay, so here's those flip-flop phrases. Subtracted from, added to, anything that uses less than, like more than, younger than, older than, any of those than terms, we're going to flip-flop the order. So 1 subtracted from, so flip-flop phrase, 1 subtracted from a number. We are going to flip the 1 to the back and the variable to the front, like that. A number added to, so added to is a flip-flop. A number, so our variable is going to flip to the back, and our 4 is going to flip to the front. 2 less than a number, so less than, the than phrases are flip-flopped. So 2 will go to the back, and our variable will go to the front. And then we are going to say is means equal. So we'll keep that part the same, but this, the expression part of this equation, so we're going to put x minus 2 equals 10. Then we have terms such as sum and difference, which will require some parentheses if we have more than one operation in our mathematical statement. So when we see the sum of a number and 3, this part is going to go in parentheses, and then we'll say times 5. So we know sum means to add, so we're going to say x plus 3, and then that sum is multiplied by 5. If we wanted to, a lot of times this 5 would actually be in the front. Either way is acceptable. Okay, and then we have the difference of. The difference of, and you can see the word of will be an indicator. 2 and a number. And because we have a second operation and we're using difference of, just like sum of, we have to use parentheses. So the difference of 2 and a number, and then divided by 6. And I'm going to say this whole thing is divided by 6. Now, since we use this long division bar, it would have been okay if we didn't put parentheses, because this long division bar indicates that we do this before we divide. So either way is okay. Okay, so now you pause the video, complete these practice problems, and this is the end of the lesson. So make sure that you check the answer key, and some of these are the answers will vary because we're coming up with our own phrases in some of the questions. So